fine, fine. Well, good evening, everybody. Hello.
Oh, good evening.
Can everyone hear me? Okay, good evening.
Yeah.
Hello, everyone. This is your teacher. Okay. So this is your teacher. My name is Gaurav, and I'm basically from Shimla, and right now I'm talking from Delhi. And I've been into this profession for past 2-3 years, and today it will be your demo session. So first of all, what I want from all of you is to introduce yourself one by one. Okay, I will take the name, fine, and what you require to do is first of all tell your name of your school and city. That's all. Is it fine for everybody?
Yes,
Hello.
Yeah.
Okay, we will start with Ahan Mehta. Ahan, can you hear me?
yes, sir, I can hear you, sir. So I am Ahan
Yeah.
Mehta. I am living in Shillong at the moment, and I am in
Okay.
APS Shillong.
Okay, good, good. Okay, Akshat.
Sir,
Akshat, can you
I'm
hear
right
me?
now in Bangalore. Yes, sir. I'm living in Bangalore and I'm from Bihar.
Okay, great, great. Next is Bushra. Bushra, I guess. Hello, Bushra. Can you hear
Hello.
me?
Yes, sir. I'm from Chennai.
Okay.
I study in Wales, Billabong.
Okay. Okay, great, great, Bushra. Next, I guess Harshita. Can you hear me? Harshita, are you there?
Yes.
Harshita, can you hear me? Hello. Yeah.
Hello?
See. Yeah, Harshita, can you hear me?
Yes.
Yeah, please, Harshita, introduce yourself, your city, name, and your school.
Actually, I'm from Bangalore, from Presidency School.
Okay, fine. Okay, fine. Uh, John, are you there? John? I guess he is not there. Okay, let's go to Navya. Hello, Navya. Are you there?
Yes, sir, I'm here.
Yeah.
I'm from Bangalore and I'm from Clarence Public School.
Okay, okay. Fine, good. Before proceeding to Neha, I want to hello. Yes.
Hello.
Before proceeding to Neha, I want to make a request every one of you to unmute yourself. Can you see the unmute button over there? So whenever it's your turn to speak, just unmute yourself. Fine? Hello? Hello? Neha? Hello, Neha. Can you hear me?
Yes, sir.
Yeah, please introduce yourself.
Yeah. So I am from Bangalore, from SFS Public School.
Okay, great, Neha. Rakshita. Yes, next is your turn, Rakshita. Rakshita, are you there? I guess Rakshita is not able to hear us. Okay, let's move on to the next candidate. Ramakrishna, can you hear me?
Sir, yeah, that's my father's name. My name is Nikhila.
Okay, fine, fine. So, yes, say Nikhila.
Yeah. Yeah, I'm Nikhila. I live in Bangalore and I study in Christ Academy.
Okay, great. Okay, next Ramakrishna, are you there?
Yeah, that's the same person, sir. Actually, my account name is my father's name.
Okay, okay, okay. That was basically Ram. Okay, Rakshita is not there. Can you hear me, Rakshita? Okay, fine, fine. I think anybody left over there? No one. Okay, great. Okay, nice to know all of you. It's great. So, can all of you see the white screen in front of you?
Yeah.
Hello?
Yeah.
Yes, sir.
Can everybody see it?
Yes,
Yeah,
sir.
Okay,
Yeah.
can they
Yes,
see the cursor moving?
Yes.
Okay,
Yes,
fine,
sir.
fine.
No. No.
Okay, okay. So, okay, let's start the session. Okay, first. Okay, first of all, I want to introduce all of you with the content of the course. Fine. Basically, this is a revision course. Fine. 15 hours revision course, and there are few topics in this course, and I'm sharing the curriculum with you. Fine. Just hold on a second. And it will contain 6-7 topics.
Yes, sir.
Just hold on a second. And starting with, first of all, we will go with just hold on a second, everyone. Okay, here are the contents. Can everybody see the contents?
Yes, sir.
Hello? So,
Yeah.
yes, there are 5 contents mentioned. Unfortunately, one content is not there. So, first of all, we will start with the first content is basically force, work, power, energy, and fine. So this is basically the first topic which is not listed here. The second we will go on with the light, sound, electricity, magnetism, heat, and modern physics. Fine. So if 15 hours there, we have divided equal number of hours for each and every topic. Right? Say 3 hours for force, work, power, and energy, 3 hours for light, 3 for sound, and here, can everybody see my screen?
Yes, sir.
Yes, sir.
Hello. So see, on 4th of Jan to 6th of Jan, all the 3 days, we will go with the force, work, power, and energy. Fine. And then on 7th, 8th, 7th, we will give one session for heat. And on 8th, 11th, 12th, we will go for the light. For 13, on 13, we will go with the sound. And from 14 to 19 Jan, it will be electricity and magnetism. And then from 20 to 22nd, it will be modern physics session. Fine. So this is basically the timetable for sessions. Okay. So now, can everyone hear me? Hello?
Yes, sir.
Yes, sir. Yeah.
Hello? Is everybody
Yeah.
there?
Yes.
Okay, okay.
Yes, sir.
So see,
Yes.
now how we are going to proceed in this revision course. See, because in physics, see, you know that numericals are important, fine, because this is a revision course, so our main focus will be on numericals, because if you are able to do the numerical, so that means the concept is clear to you, fine. So how we will go forward, that we will first of all select the topic, we will select the question, fine, we will do the question, we will find all the concept that is there in the question, and then we will take the reverse approach. I mean to say, whatever the concept is used in the numerical, what we will do, we will discuss that concept there only, and then we will go with the solution. Fine. So this is how we will proceed. So can everybody see can everybody see the question?
Yes, sir.
Yes, sir.
Yes, sir.
So who is going to read it out? Hello? Anyone? Anyone who would like to read it out? Okay, Neha, are you there?
Hello?
Hello? Neha, are you
Hello?
there?
Yes, sir.
Neha, are you there? Can you read the question?
Yeah. Calculate the
Yeah.
resultant torque from the following diagram.
Okay, great. So what we are asked is to calculate the resultant torque. Fine. Now you can see there is a body. Fine. There are different forces which are acting on the body at every point, and you know this point Can everybody see the point O? I think everybody can locate the point O. Fine. Now, this body is going to rotate about this point O only. Fine. So we need to calculate the torque of each and every force about the point O only. Fine. Now, first of all, let's understand what basically torque is. Fine. So, torque, basically, how do we define torque? It is basically the rotational effect of a force. Fine. Rotational effect of force. Now, what does I mean by this rotational effect of force? So, you know, every one of you, every day, let's take an example. Suppose I have a, now what do I mean by rotational effect of force? Suppose I am having a door, fine? Every one of you do it every day, fine? Suppose this is a toe, and what I do, it's a handle over there, fine? Now what happens when you apply the force at the handle, and this door is fixed to this axis? Now suppose you are applying F force here. Now what happens to the door? Can anyone tell me? Hello? Yes, Neha?
The door, we can open or close the door.
Yes, yes.
Yeah, actually,
Yeah,
torque is
open the close and door. So basically, yes, yes.
So, because of the torque, the door, like, it rotates about the axis.
Yes, yes. Yes, of course. See, it's a, suppose this is the axis, x and x prime is the axis, right? And I am applying a force from here, this point. Now what this force is going to do, this force is basically going to rotate this door in the clockwise or in the anti-clockwise direction. Depends upon if the direction of your force, right? So how do we define torque? And sometimes we also call it moment of force. This torque is also termed as moment of force. Now, this, how do we mathematically define the moment of force or torque? Is basically the force that we are applying, yeah, multiplied with the perpendicular distance from the axis of rotation. From the axis of rotation. Right? Fine. So coming back to this question. Now see, I am having 3 forces. One is first force. So if I want to calculate the torque of this force, 30 Newton force, about this point O, so how am I going to calculate? Suppose 30 multiplied by 4. And this, what is this 4? Basically, 4 is the perpendicular distance between the point O and the force. Now, what do I mean by force? Is basically the direction of force. See, 30 Newton. Can everyone see the direction of force of 30 Newton?
Yes.
Yeah. So this is basically the direction of force of 30 Newton, and this part. This is basically the perpendicular distance between the O and the direction of force, which is 4. So this basically 30 into 4 is basically 120. So that means 120 is basically, in SI unit, 120 is my torque. Fine. Now the unit for torque is Newton meter. Fine. Because the unit of force is newtons and 4 is the distance is meter. Fine. Now next is, okay, now next is to find the direction of this torque. Fine. Now what do you all guys think? What will be the direction of this torque? Now see, here I am telling you, this is point O, this is 30 Newton torque. Now obviously this is 4. Obviously this will try to rotate this like this in a clockwise direction. Fine. So the direction of this force is, this torque will be in the clockwise sense. Fine. Similarly, what we need to do, we need to calculate the torque due to all the rest of the forces. 2, 3, 4, 5, along with the direction. Fine. So one more point to note here, that if you see this force, 200 Newton force, and if you calculate the torque for this 200 Newton force about this point O, this will be 0. Now the reason is obvious, because the line of action of this force passes through point O. Now if it passes through point O, definitely the perpendicular distance between the line of action of this 200 Newton force and the point O is 0. That means by this part, the perpendicular distance is 0. That means torque due to this 200 Newton force is going to be 0. Isn't it? Now can everyone quickly calculate it and tell me the answer? Hello?
Yes,
Are you
sir.
there? Yeah.
Yes, sir.
600.
Just try it out.
600.
Sir, is it 630 Newton meter?
Yes, here it is.
Sir, you're supposed to find out each one and then you have to add all, right?
Yeah, then you add off. Okay, let's see. Let's do it here. I guess
So
everybody is
I
trying.
got down.
Yes, yes. Okay, first of all, let's calculate the torque due to 30 Newton force. Fine. So the due to 30 Newton, it will be 30 into 4, that is 120, and the direction will be clockwise direction. Fine. Now let's calculate due to this force 20 Newton. Right? So the torque will be due to 20 Newton will be 20 into 1, that will be 20, and the direction will be anti-clockwise.
Anti-clockwise.
Yes, of course, anti-clockwise. Next comes, let's calculate due to 80 Newton force. Fine. So now how much will the torque will be? 80 into 3, because 3 here is the perpendicular distance. It will be 240, and the direction will be anti-clockwise. Isn't it? Yes, once again anti-clockwise. Okay, next comes due to the 200 Newton. The torque will be 200 into 0, that is equals to 0. Right? Why? Because the perpendicular distance, as I told you, the perpendicular distance of this force about this point O is 0. Yes. The final is 50 Newton. Now, due to this 50 Newton, the torque will be 50 into 5, that is 250, and the direction will be clockwise. Fine. So we have calculated the torque due to all these forces. Now what is next task? Next is to add up all these torques. Right? First of all, let's add up all the clockwise torques. Right? So how much? This one is clockwise 120, and this one is clockwise 250. So the net clockwise torque becomes 120 plus 250 is basically 370. Fine. Now next calculate add up the anti-clockwise torque. So we have this 20, 240. So how much it will become? 260 along with the sign Newton meter anti-clockwise torque. Fine. Now what we will do finally, we will calculate the net torque. So net torque in this case will be clockwise plus anti-clockwise. Right? Now see, if you are now one of you, one of the clockwise or anti-clockwise, you have to take as a positive, and if you take clockwise as a positive, then you will take anti-clockwise as negative.
Negative.
Right?
Negative.
Yeah, negative. Yeah, negative. Yes. So clockwise you can write it as 370, and anti-clockwise you can write it as minus 260. Right? So it will become 110, and in which direction it will become? Basically clockwise. Why? Because the magnitude of clockwise is greater than the magnitude of anti-clockwise. Fine. So is it clear to everyone?
Yeah.
How we did this question?
Yeah.
Everybody clear? So this is how we calculate the torque and how we calculate the net torque. Fine. So, okay. So in the same way, I am just sharing one more question with you. Fine. Just hold on a second. Just hold on a second. Can everyone see the question? Hello?
Yeah.
Can everybody see the
Yes, sir.
question?
Yes, sir.
Okay. Will anyone read it out? Please,
A
anybody.
uniform meter rod of weight 50 grams is balanced on 40 centimeters.
Actually, I am not able to see your names through my window chat, so I don't know. So Sushan, sorry how I am pronouncing Sushan. Are you
Susanna.
there?
Yeah.
Susanna, sorry Susanna.
Yeah.
Are you there? Please read the question.
A uniform meter rod of weight 50 grams, force is balanced at 40 centimeter mark. A weight of 100 grams force is suspended at 5 centimeter mark. Where must a weight of 80 gram force must be suspended to balance the meter rod?
Yes, of course. So I guess everybody has read it out. So I request everybody to read it themselves. I'm just giving 15 seconds. Just read it themselves and understand the question. Then I will
Hello?
proceed with the answer.
Hello?
Hello? Yes.
Hello?
Yes. Yes, yes. Please read the question. Everybody please read the question for 15 seconds. Then we will start with the solution. Okay, I guess. Okay, I guess everyone has done with the question. So see, the question says a uniform meter rod of weight 50 gram force. Right? Now, everybody must be knowing what 50 gram basically means. 50 gram force means basically 50 into, because this is in the CGS unit. So okay, let's take it as a 50 gram force. Right? Now here is the rod. This AB is basically a rod. Right? Now the weight of this AB is basically 50 gram force, and obviously if the weight is 50 gram force, where this weight will be acted at the center of rod. Fine. Now what I am doing, what is shown in the figure, that this rod, we start calculating the distance of the rod from this point A, from the left end. We take A as a 0 and we will proceed to the right, and we will reach the point B where the length of the rod is 100 centimeter. Right? So definitely if the weight of this rod is 50 gram force, so this entire weight will be acted at the
Hello, sir, can you
center
hear
of
me?
the rod. That is, yes, I can hear you.
Hello?
Sure.
Sir,
Fine.
can you hear me?
Yes, I can hear you. Yes, Ahan, I can hear you. Fine. So obviously this 50 gram force is basically will be acted at the center of this rod. Fine. So now Next, what is said that this rod is balanced at 40 centimeter mark. Now 40 centimeter mark, if you want to mark 40 centimeter, we will mark it from the left end only because our reference point is at the extreme end, that is point A. So 40 centimeter is basically at point C as shown in the diagram. So basically this is balanced over here with the help of some sort of hinge or some sort of support. Fine. Now next it says a weight of 100-gram force is suspended at 5 centimeter mark. So here it is 5 centimeter mark where the weight of 100-gram force is basically it is hanged or it is suspended. Now next it is asking where must a weight of 80-gram force be suspended to balance the meter rod. Now what we want that this meter rod, that is AB rod, fine, it should be balanced. It should be balanced means it should lie completely in equilibrium, that is in the vertical direction, in the horizontal direction. Fine. Now it is asking now where this 80-gram force, where exactly this 80-gram force should be hanged so that this entire rod AB it remains balanced at point C. Fine. So everybody got the question? Hello, Ahan, can you hear me? Hello. Hello.
Yes, sir.
Yeah, Ahan, can you hear me?
Yes, sir, now I can hear you.
Yeah, fine. So I guess everybody is able to hear me. Fine. So did everybody understand the question?
Yes, sir.
Everybody understand the question. Anybody who has not got the question? Hello. So now what? Okay, let's move ahead. Okay, now what we need to do in this question. Now since it is asking us to balance the entire bridge across this point C, obviously when there is a condition for balancing, now condition for balancing is basically the torques should be equal, same. I mean to say the net torque at point C should be 0. Now what do I understand with net torque at point C is that all the clockwise torque plus all the anti-clockwise torque should be 0. Fine. Now, now let's say we will suppose that this 80-gram force is basically hanged or suspended at a distance x from the left end. From it, this distance x is basically from the leftmost part, that is from A. Right? Now what we will do, we will calculate all the clockwise torque and all the anti-clockwise torque first of all. Fine. So now you can see we are having how many weights we are having, how many forces are acting on the system. Force number 1, that is 100-gram force. Force number 2, that is 50-gram force, and force number 3, that is 80-gram
80 gram.
force. Right? Now all these forces will be having torque whether in anti-clockwise or in clockwise direction. Right? So first of all, let's calculate the torque due to 100-gram force. It's fine. So how much torque it will provide? Basically, now see, the formula for torque is force into the perpendicular distance. Right? Now the force is 100-gram force multiplied by perpendicular distance. I mean to say perpendicular distance between the force, line of action of force, and the axis of rotation. Now here in this case, since I have to balance this entire rod AB from point C, at point C, so obviously C is my axis of rotation from where it will try to rotate.
Yes,
So if you can see the diagram, because from the left end A, or let me take this point as E, because it is given the distance between A is 5 centimeter, and also the distance between A and C is also given, which is 40 centimeter. Then obviously the distance between E and C becomes 35 centimeter, and this is the distance and this is the same distance that I need to put here, 35 centimeter. Fine. Or so it will be basically 3500, fine, and in serious units. In serious units, fine. So now I need to see if this torque is clockwise or anti-clockwise. Now obviously this clock is going to rotate like this, so it will be in anti-clockwise direction. Fine. Now let's calculate the torque due to 50 gram force. In the same way, it is mentioned, as I told you earlier, this 50 gram force is being acted at the middle of the rod, that is a 50 centimeter. Now let's take this point as F. Now the torque due to this 50 gram force will be 50 into how much is the perpendicular distance? Yes, An? Hello? Hello? An, can you hear me? Who else is there? Can you guys repeat your name? Anybody? Because I am not able to see the list of your names here. Hello? Hello?
Hello, sir.
Yeah,
Hello?
Akshat, can you hear me?
Yes, sir.
Akshat, can you hear me?
Yes, sir.
Yeah, can
Okay,
you
so
tell
now
me
I'm
what will be the
I was
torque due to this gram force? 50 multiplied by what is the perpendicular distance of this 50 gram
10
force from the
centimeter.
axis of rotation?
10 centimeter. So that's 500
Yeah,
gram force clockwise.
yes, 10 centimeter is the distance. So it will be basically 500 and the direction will be clockwise. Fine. And the rest, one more force is left, that is 80 gram force. Right? Now see, the torque will be in the same way, it will be 80 multiplied by, now the distance between C point, and let's take this point G. C and G will be basically x minus 40. X minus 40. Now you can calculate it yourself, because still my AG is basically x and my AC is 40. So obviously my CG will be x minus 40. So I will put it as x minus 40. So now what we need to do, that we need to add up all these forces, all these torques, that is 3500, 500, and whatever is the multiplication product of this thing, 80 into x minus 40 with the sign. Right? Now again this 80 gram force will be clockwise. Right? Now let's assume that anti-clockwise torque, let's take anti-clockwise as a positive and clockwise as a negative. Now let's add them as a with the sign and equate it equals to 0 here. Let's use this formula. So once again I'm using it here. So clockwise, let's take clockwise, minus 500 minus 80 into x minus 40, right, plus anti-clockwise is 3500, and now equate it equals to 0. Right? Akshat, yes, can you tell me the answer? If anyone?
So
Anyone, if anyone is calculating it? Can anyone? Has anyone got the answer? Okay, you try it. Till then, I just upload the answer in your next slide. Yes. Can everybody see the answer? Hello?
yeah.
Yes, sir.
Yeah. Can you see? Have you got the answer? How we did it? See,
Yes, sir.
now what they have done here in this case, what they have done in this case, they have basically used the same thing. anti-clockwise plus clockwise equals to 0. That means anti-clockwise equals to negative of clockwise. They have equated both the terms, right? Equated and got the value of x in this case. So your x will be basically 77.5 centimeter. Fine. Hello. So shall we move on to the next question?
Yes, sir.
So this is till now you might have understood that what torque is and how do we balance the torque, what are the equilibrium concepts. So let's move on a different kind of question, and we will take that question from the motion part, right? From the laws of motion and from the straight line equations. I guess everybody might have studied the straight line equation. So here is the question. Can everybody see the question? So you forgot the name. Susanna, yes?
Yeah.
Yeah. Susanna, yes, please read the question.
Yeah. A bullet of mass 10 grams traveling at 200 meters per second penetrates a target in 0.1 seconds before coming to rest. Find retarding force and distance through which it penetrates.
Yes. So everybody please read the question. 15 seconds. Just read it out. Then I will explain what the question is basically. Everyone done? Hello? Is everyone done with the question?
Yes, sir.
Okay. Harshita, are you there?
Yes, sir.
Okay. Actually, unfortunately, I'm not able to see the list of your names, so I don't remember the name of all of you. So anyway, you keep on, you make the session interactive and mark your presence field to me, so that I know you are there attentively. Yeah. So that's the problem with it. So okay. So see, what the question is basically, we have a bullet, fine, and the mass of bullet is 10 grams. Suppose, say, this is a bullet and the mass is 10 grams. Now it is traveling with 200 meter per second. So that means let's take this thing as a u. Now u is basically initial velocity of this bullet. Initial velocity, right? And the mass of the bullet is basically 10 grams. Right? Yeah. Now this is the target. Suppose this is the target. Right? Now what happens? It will strike the target, right? And in 0.1 second, after 0.1 second, suppose it reaches this point. It travels the distance s from A to B. It travels the distance s, and at B, it comes at rest. So basically, my final velocity at B will be 0, because obviously after a while it will come to the rest. Right? Here, initial velocity was 200 meter per second. Right? Now, what we need to calculate? We need to calculate this distance s. What basically this distance s is. And second thing, we need to calculate what is the retarding force. Retarding force. Now, uh, first of all, let me explain what is retarding force basically. Obviously, when this bullet will, yes, when this bullet will start penetrating this target, what will happen? This target will exert equal and opposite force on this bullet. Right? This is the principle of, this is the basically third law of Newton. Everybody might have heard about it. The third law of Newton says that to every action there is equal and opposite reaction.
Yeah.
Obviously, yeah, bullet strikes this solid target. So obviously bullet is going to exert a force on this target, and the same amount of force will be exerted back, which is termed as retarding force by this target on the bullet, and the result will be that this bullet will be stopped at point P, and the final velocity will be equal to 0. Now, yes. So therefore, we have to calculate this retarding force F, and we have to calculate the distance S. Now, force is simply, according to second law, the formula for force is mass into acceleration,
Yes.
right? Now, mass is, this force is being exerted on bullet, so the mass here will be definitely a bullet only. We will consider the mass of bullet only, right? Because this force is exerted on the bullet, right? Now, in order to calculate the force, this thing is unknown. That means our acceleration is unknown. Now, what we need to do, first of all, we need to find out the value of this acceleration. So now, for this, we will take the help of straight line equation. We will now, which equation we will use? V equals to U plus A T. Yeah, everybody might have heard about this equation. This is the basically straight line one-dimensional equation. Now here V is basically the final velocity of the bullet. Final velocity, as you can see here, is 0. U is basically initial velocity, which is 200 meter per second. A stands for acceleration and T stands for time of travel, which is all again given. It is given 0.1 second. Right? So with the help of this formula, we can calculate this acceleration. Right? So if you see, put the values. So once again, I will get 0 equals to 200 plus the acceleration into 0.1. So from here, acceleration, if you rearrange this thing, will be negative 200 divided by 0.1, that is negative 2000. Fine. So here this acceleration I have is minus 2000. Now what does this minus 2000 stands for, and the unit for acceleration is meter per second square. Right. Now what does this minus 2000 stands for? Minus sign stands for? Minus stands for that the acceleration is basically a retardation. Fine. That's why, yeah, that's why it is in negative, it is along with the negative sign. Right? Now from here, since you have calculated the acceleration, you can calculate the retarding force. The force will be mass into acceleration. Now mass is given, that is
Hello.
10 gram. Yeah, hello. That is
Sir,
10 gram.
can you hear me?
Yes, 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 I can
Again
hear you.
lost audio. It is coming
Okay, no
and going,
problem.
so I sorry if I'm disturbing that session.
No problem. You can fix it out. So the mass is once again 10 gram divided by, if 1000, it will become in kgs, fine, and the acceleration is minus 2000 in SI units, meter per second square. So if you solve this thing, I will get retarding force equals to negative 20, and the unit of force is newtons. Now once again the force is in negative. This thing implies that this force is basically retarding, and retarding force which is exerted by the target on the bullet. Fine. So this is how we have calculated F. Now next task is to calculate S. In order to calculate S, we will use the another straight line equation. You might have heard about this. Yeah, yes, correctly. Who said it? Yeah, who said it? Yeah, Susanna, right. Yes, you are absolutely right. We will use another term, that is another equation, that is v square minus u square equals to 2as. Now here also, acceleration we are knowing, negative 2000. S we have to calculate, fine. Acceleration is negative 2000. And u also we are knowing, that is 200. V basically is 0, the final velocity after the bullet stops. So this way we are going to calculate the S. Now Susanna, can you tell me the answer? If you can.
Yeah, just
Till then, in next page, yeah. till then in next page I'm just uploading the answer.
Yeah.
Everybody try it. Yeah, did everybody got it? Abid, sorry, are you there? Abid.
10.
Ahan, are you there? Just say yes. Whose name I Akshat. Anita? Hello?
Yes, sir. I can hear you, sir.
Yes, sir.
Anita? Harshita?
Yeah.
Is everybody present? Now I have got the list of all, so I am pronouncing your names. Navya?
Yes, sir.
Neha? Susanna?
Yeah, sir.
Neha and Susanna? Okay, fine. You guys are there. Fine. So, can everyone see the question?
10.
Yes, sir.
Yeah. So, did everybody get the question?
Yeah.
Yeah. So here you can see the same way. The first they have used this. They have find out this acceleration here, which is equals to negative 2000 meter per second square. Next is the force. They have calculated using the formula mass into acceleration. That is equals to negative 20. Next,
Again, I lost
same
okay.
formula.
Sir, can you
Yeah,
help
v
me?
square minus u square equals to 2as. And from there they have calculated s, which is equals to the cloud to be equals to 10 meters.
I can see what
Right.
you are doing, but I cannot hear you.
Right. Okay. Okay. So now I'm uploading the last question in front of you as an assignment. You can do it at your home. Fine. So the question is, yeah. It's a very simple question, and this question is basically related to the work. Fine. So here's the question. So Neha, can you read out the question?
Yes, sir.
Yeah, please read
An,
it
ele-
out.
an elephant takes tourists to a hill resort 0.4 kilometer above the ground level. The elephant carries 2000 kg load of tourists and luggage and takes 60 minutes. Calculate
Yes.
the work done by an elephant, potential
Yes.
energy gained by tourist and luggage, efficiency
Yes.
of the operation and power of the elephant in horsepower.
Yes, of course. See, so yeah, 10 seconds, everyone. Please read out the question by yourself. An elephant takes tourists to a hill resort 0.4 kilometer above the ground level, and it carries 2000 kg load of tourist and luggage and takes 60 minutes. And the mass of elephant is also given, which is equals to 5 tons. 5 tons is basically equals to 5000 kgs. Fine. Now, four things are there that you have to calculate. The first is you have to calculate the work done by the elephant, potential energy that is gained by the tourist and the luggage, efficiency of the operation, and the power of elephant in horsepower. Fine. So now, see, let's go with the first part, that is work done. Now, work done, as you know, work done is basically force into displacement. Everybody knows that. Right?
Yes.
Now, which force is which force is applied here? Which force? Basically, work is done by
2000.
which force? Gravitational force, isn't it? Because you know what elephant has done basically? Elephant has basically lifted, you know, is his own weight, that is 5000 kg plus the 2000 kg load of tourist and luggage up to an height of how much? 0.4 kilometer. That is equals to 4000 meters. So obviously, which against which force it has done the work? Gravitational force. Yeah, that is equals to the mg. Right? Now, how much mass he has lifted? Basically, 7000 newtons, 7000 kg, 7000 kg in totality, and the value of g we can take it as 10. Fine. So this much force is being fine. So here, how much will be the force? Basically, 70,000 multiplied by the displacement. If we take the displacement in is equals to 4000 meters. Fine. So this much work will be done by the elephant. Is it clear?
Yes.
Hello. Yeah. The another method that you can remember is that the work done formula, work done by the gravitational force, which is equals to mgh. Work done is equals to mgh. So it's the same thing. Force, mg stands for force and h stands for the displacement in vertical direction. So here force is once again the same thing. Force is mass into gravity. Mass once again is basically 5000 plus 2000, that is 7000. G is acceleration due to gravity. Roughly you can take it up to 10. Height you can take whatever is height is given here, 0.4 kilometers. You take it in meters in SI units. So this is work done. Fine. So now next is how much potential energy is gained by tourist and luggage. Right? Only tourist. It is asking potential energy gained by tourist and luggage. And you know what is the formula for potential energy here? The formula for potential energy is basically mgh. Now it is asking about the potential energy of tourist and luggage only. So the mass of tourist and luggage will be considered here, which is given equals to 2000 kg. 2000 kg. Once again, the value of g we can take roughly equals to 10. The height we can take 4000. Fine. So once again, you can calculate this thing. Right. Next part is you have to calculate the efficiency. Now efficiency is basically, how do we define as the efficiency is basically the useful work done divided by the total input.
Work input by work output.
Yeah, input supplied. Now what will be the useful work done? Basically the useful work was to lift the tourist and luggage only. Fine. So now let's see. Now this change in potential energy that is gained by tourist and luggage is equals to the work done only. You might have studied that this potential energy is equals to the work done. So this term divided by the total work done. Now the total work done is here in part A we have calculated. So if you divide both these terms, you will get the efficiency. This part take it as 1 and take it as 2. So you have to divide 1 divided by 2. You will get the efficiency. Yeah, you will get the efficiency. And rest power if you want to calculate. So the formula for power is basically the work done divided by the time taken. Now time, as you can see here, is given in minutes, 60 minutes. So you can convert this 60 minutes into seconds. That is 60 into 60, that is 3600 seconds. And you can calculate the work. Work here you will take this one, the total work, this one. And so this is the way how you will get power. Now you will get this power in joules, in watts. The SI unit of power is watt, right? Which is equals to joule per second. Now, it is basically asking the power in horsepower, but we will get it in watt. So what relation you need to apply? You need to apply this relation. I am writing at the top. Now can anybody tell me the relation between watt and power and horsepower?
1 watt is equal to 746 watt is equal to 1 horsepower.
1 horsepower. Yes, yes, tell me.
Is equal to 746 watts is 1 horsepower.
746 watt. Is it what you are saying?
Yeah. Yeah.
Okay, anyone else? What's the relation between watt and power? Okay, in the next page, I'm uploading in the next slide. I'm uploading the answer. Just a second. Yes, that was right. 1 horsepower equals to 746 watt. So yeah. So just number that form. Yes. So here's the answer. Right? Yeah. Yes. And in the last part, you need to apply this formula. 1 horsepower equals to 746 watt. Right? So this is how you will get the answer. This is the answer I have uploaded to everyone.
Yeah.
Right? Yeah. So everybody is yes. So we have discussed 3-4 questions today. So basically, this is how we are going to proceed. We will just focus on the numerical part, and along with that numerical, we will study and we will discuss the concepts. Okay? Yeah, next time onwards we will, because today's section was what I found was little bit less interactive. So whenever everybody will be getting chance, what we will do, I will be getting a response, because today I was not able to first of all recognize your name because the list was not there. So I could not ask if you are knowing the concept or not. So in that case, we will discuss the concepts thoroughly, even if somebody is not
Again,
aware with
audio
the
cut.
concept. We'll go like this with the solution of the question. Fine.
Yeah.
So everybody present. Aaron, Abid, Mahan. Yes. Hello. Abid, are you there? Okay. In between, I'm hearing some disturbances. Someone has switched on their television. Can they mute? Yeah. Hello. Yeah. Yeah. Anyone of you has turned on their television? Can they mute it or? Yeah. Can they mute the television? So yes, Abid, Ahan, Akshat, Navya, Neha, Susanna.
Yeah.
Are you there?
Yeah.
Yes, sir.
So I hope you all have understood the questions and solution, the concept also. Right?
Yes,
So
sir.
so let's hope next time we will make it little bit, more interactive, so that
Yes, sir.
we will, this was just a demo part. So next time we will follow the proper framework, the proper the proper timetable, the proper concepts, and we will streamline the entire thing. So yeah, so it was nice to have a session with you guys. Hope all of you has really enjoyed it, right? So okay, so now anyone want to say, as I am just turning off the session.
Thank you,
Okay,
sir.
then.
Yes, sir.
Take care, everybody of you.
Right, sir.
Right.
Thank you, sir.
Okay. Okay. Goodbye. Take care.
Hello. Hello. Hello.
Okay. Someone has been here.